For a few weeks in late 2025, Google looked like it had finally won the AI race. Gemini 3 Pro launched in November and immediately reached number 1 on LM Arena with an ELO score of 1501. Google reported 37.5% on humanity's last exam, and for a brief period, it was the best AI model in the world. For once, Google wasn't playing catch-up, it was ahead. And then the rankings changed. Today, Gemini's flagship 3.1 Pro is nowhere near the top of the overall public preference rankings, while Claude and GPT models occupy much of the upper tier. But here's the strange part. Despite not having the best models, Google's AI business is not collapsing. At the end of 2025, Google said that the Gemini app had surpassed 750 monthly active users. More than 8 million Gemini enterprise seats had been sold, with over 120,000 enterprises using Gemini and its first-party models through direct API calls. And just recently, and we are talking like a couple weeks ago, Gemini passed 1 billion monthly active users. They may not have as many users as ChatGPT right now, but they are slowly catching up. So this is not a story about how Google is failing at AI. It's a story about how Google having one of the strongest positions in the AI industry while somehow losing the perception that it makes the best AI. And the latest Gemini release makes the contradiction even more interesting, because on August 13th, Google released its Gemini 3.7 Flash model. And instead of trying to announce another giant frontier model that beats everyone at everything, Google is doing something much more interesting. It's making AI cheaper, a lot cheaper. The first thing to understand about Google's AI problem is that Google didn't arrive late. Google helped build the technology everybody else is using. In 2017, Google researchers published a paper called Attention is All You Need, introducing the transformer architecture that became the foundation for modern large language models. Google had already spent years building the machine learning infrastructure. It developed tensor processing units specifically designed for AI workloads. DeepMind had produced AlphaGo, AlphaZero, and AlphaFold, revolutionizing how machine learning is used to tackle complex problems at the level of a human being. And Google had an enormous advantage that OpenAI and Anthropic simply didn't have. Google already owned the infrastructure through which billions of people interacted with their software. Search, Android, YouTube, Gmail, Workspace, Chrome, Cloud. You say it, they had it. So when ChatGPT exploded in November 2022, Google's problem wasn't that it didn't understand artificial intelligence. It was that OpenAI had turned AI research into a consumer product faster. That distinction became Google's problem for the next several years. First, they came out with Bard. First of all, a terrible name, which they then rebranded to Gemini. And Google kept improving the models. Gemini 1.5 pushed context windows to 1 million tokens. Gemini 2.0 pushed multimodality and agents. Gemini 2.5 became genuinely competitive. And then Gemini 3 finally looked like the model Google had been trying to build all along. For a brief period, Google was number 1. So the obvious explanation, Google just cannot build good models, really doesn't work here. The harder problem is what happens after you build the model. OpenAI can optimize ChatGPT around being a great AI product. Anthropic can optimize Claude around being useful to technical and professional users. Google has to deploy Gemini across an enormous ecosystem. And that creates competitive incentives. The model needs to be capable, but it also needs to be safe. It needs to work inside Google's products, and it has to behave predictably at enormous scale, coexisting with businesses like search and advertising. We have already seen what happens when Google's safety systems become too conservative. During the Gemini image generation controversy, Google acknowledged that the model had become way more cautious than we intended. That was an extreme example, but it exposed the basic problem. Users don't experience a model as a benchmark, they experience it as a tool. If one model gives you the answer you want, and another spends 3 paragraphs explaining why it cannot help you, you don't care which one got a better score on some academic benchmark. You use the one that gets the job done. No wonder why so many people are using Grok for some nefarious stuff. And once a model develops a reputation for being annoying, overcautious, and inconsistent, their reputation becomes part of the product. This is one reason I wouldn't describe Gemini's recent problems in simple terms like the model got worse. Some competitors legitimately got better. Some of Gemini's behavior has been constrained by safety tuning. Right now, it is impossible to generate any image of any public personality doing anything on Gemini and not get this stupid warning. And Google's product strategy has become increasingly complicated. Those are different problems, but they all produce the same result. People start looking elsewhere. This is where Google's position becomes uncomfortable. Google still has one of the largest AI research organizations. Demis Hassabis has pushed back against the idea that Google has somehow lost its entire research bench. But some of the people who have left are difficult to ignore. Noam Shazir, one of the authors of the Transformer paper, left Google for OpenAI. John Jumper, the AlphaFold researchers who shared the 2024 Nobel Prize in Chemistry with Demis Hassabis, and David Baker left Google DeepMind for Anthropic. But the most significant departure, in my opinion, is of this guy named Jeff Dean. Now, if you don't already know, Jeff Dean has been with Google for over 27 years. This is a man that has developed some of the most transformative technologies in human history. The guy's resume is absolutely insane. The sheer amount of things that this man has worked on is absolutely mind-blowing. Even a small contribution to any one of the projects that this man has been a part of would be enough to catapult an engineer's career into orbit. This man has been at the frontier of developing some of the most advanced technologies in computer science, machine learning, and artificial intelligence. And according to Jeff Dean, Google had already made a ChatGPT-like LLM that the employees of Google were already using during the pandemic. Listen to Jeff Dean describing that product on Dwarkesh Patel's podcast.
Sure. I think, we've been working on language models for a long time. Noam's early work on spelling correction in 2001, the work on translation, very large-scale language models in 2007, and seek-to-seek and word-to-vec, and more recently transformers, and then BERT and things like the internal Mina system that was actually a chatbot-based system designed to kind of engage people in interesting conversations. We actually had an internal chatbot system that Googlers could play with even before ChatGPT came out. And actually during the pandemic, a lot of Googlers would enjoy everyone's locked down at home, and so they'd enjoy spending time chatting with Mina during lunch because it was like a nice engaging lunch partner. And I think one of the things we were a little our view of things from a search perspective was like these models hallucinate a lot and they don't get things right correctly, a lot of the time or some of the time. And that means that they aren't as useful as they could be. And so we'd like to make that better. And from a search perspective, you want to get the right answer at 100% of the time, ideally, and be very high on factuality. And these models were not near that bar. But I think what we were a little unsure about is that they were incredibly useful. Oh, and they also had all kinds of safety issues, like they might say offensive things, and you had to work on that aspect and get that to a point where we were comfortable releasing the model. But I think what we kind of didn't quite appreciate was how useful they could be for things you wouldn't ask a search engine, right? Like, help me write a note to my veterinarian, or like, can you take this text and give me a quick summary of it, or whatever. And I think that's the kind of thing we've seen people really, flock to in terms of using chatbots as amazing new capabilities rather than as a pure search engine.
And Thibaut Saribos, who goes by the name Thibaut on Twitter, who currently works at OpenAI, while replying to a tweet mentioning that interview, says, and I quote, "I was part of that team. Basically ChatGPT 1 year before it came out, called LM Chat and then another code name. Google was too nervous to release it, and DeepMind was blocked from shipping products that could disrupt Google. I think about this a lot." So basically, Google, to save its monopoly on search, shot itself in the foot and let OpenAI get the lead in LLM chatbots. Google lost Jeff Dean, Sanjay Ghemawat, Oriol Vinyals, Ko Lee, and Kuo Lee, I'm sorry if I'm mispronouncing his name, who left to build Discovery Loop, their own AI venture. And again, this doesn't mean that Google is running out of scientists. It doesn't mean that Anthropic has stolen Google's entire research department. The important question is different. Why are some of the most valuable AI researchers on Earth willing to leave Google at exactly the moment AI has become the most important technology in company's history? And one possible answer is organizational speed. Google is enormous. Its AI research operation is enormous. The product ecosystem is enormous. And frontier AI doesn't particularly care how large your company is. A 3-month delay can matter. A model that was number 1 in November can be ordinary by August. And Google's latest release illustrates exactly how fast this race has become. On July 21, Google released Gemini 3.6 Flash. 3 weeks later, on August 13, they released Gemini 3.7 Flash. 3 weeks. And the interesting thing about 3.7 Flash isn't that Google claims it is the world's smartest model. Google is positioning it as a workhorse for coding and AI agents. The improvements are heavily concentrated in exactly the areas where companies are starting to deploy AI commercially. The model has seen significant improvement from its predecessor on almost every technical benchmark. But these benchmarks are improvements in the kind of tasks companies actually want AI agents to perform. Writing code, debugging code, operating software, reading documents, and executing multi-step workflows. And then Google does something even more interesting. It cuts the price. Gemini 3.7 Flash is launching at 75 cents per million input tokens and $3.75 per million output tokens through the end of 2026. That's half the original price of Gemini 3.6 Flash. On January 1, 2027, the permanent price becomes $1.5 per million input tokens and $7.5 per million output tokens. Now compare that with Google's most expensive competitors. On Google's own comparison table, Claude Sonnet 5 is listed at $2 per million input tokens and $10 per million output tokens. GPT 5.6 Terra is listed at $2 and $12. Gemini 3.7 Flash is 75 cents and 3.75 during the promotional period. So Google is not necessarily trying to win, it's saying our model is good enough to run your entire workflow and we are going to make that cheap. This is a really different strategy. It's a strategy that makes sense for Google because AI agents don't make one API call. They make lots of them. They read documents, they call tools, they write code, they check the result, they retry, they call another tool, and then they do it again. Companies expect these AI agents to perform a copious amounts of tasks. If an agent needs thousands or millions of model calls, token economics suddenly become much more important than whatever one model wins in a benchmark by 3 percentage points. Gemini 3.7 Flash has a 1 million token context window, supports configurable reasoning effort, and is designed around multi-step tool use and agentic workflows. Google is immediately putting it into its Gemini Enterprise Agent platform, AI Studio, Anti-Gravity, and Android Studio. It is also powering Gemini Spark, Google's personal AI agent, for Pro and Ultra subscribers in more than 160 countries. So the latest Gemini release tells us something important about Google's strategy. Google may be moving away from the idea that the most important AI product is simply the world's smartest chatbot. And Google has another advantage. They make their own chips. Its latest TPU generation, Ironwood, can scale rapidly to accommodate rising AI demands. Google says their latest generation Ironwood delivers more than 4 times the performance per chip of its previous generation. That matters because the economics of AI eventually comes down to something extremely boring. How much does it cost to run the damn thing? Google doesn't need to buy every unit of compute from Nvidia. Google designs their own accelerators, they operate their own data centers, they own a cloud platform that hosts and trains Gemini on that infrastructure, and then it sells access to that same infrastructure to other companies. That's one heck of an example of vertical integration if I've seen one. And it gives Google an advantage that doesn't show up on any benchmark. If the future of AI becomes millions of autonomous agents making billions of model calls, then inference efficiency becomes significantly important. And that's exactly where Google's Flash strategy starts to make sense. Now Google's latest model doesn't compete well with the Pro models from Nvidia and Anthropic. It has been reported that after months of delay of Gemini 3.5 Pro, Google has basically shelved the idea and are skipping 3.5 Pro for Gemini 4. We still have to wait and see how it performs against other Pro models from Anthropic and OpenAI. But as a Flash model on its own, it seems to be doing the job that it was designed to do quite well. There is another reason Google is pushing down the price, and that is open models. DeepSeek and other Chinese and open-weight developers have been putting pressure on the economics of AI by producing increasingly capable models at extremely low prices. You can pay OpenAI, you can pay Anthropic, you can pay Google, or you can take an open model, host it yourself, customize it, and build your own software layer around it. For some enterprises, the difference between the world's best model and the 5th best model is less important than the difference between paying $10 million a year for inference and paying $2 million. This is why the AI market could eventually separate into 2 different competitions. One competition is who has the smartest model. The other is who can provide enough intelligence at a low enough cost to run it everywhere. Google has a plausible argument in the second competition, and Gemini 3.7 Flash is basically a demonstration of that strategy. But there is still a big problem, because while Google is becoming extremely good at the economics of AI, it still hasn't completely solved the product problem. And this is where the developed flagship model becomes important. Google has just released 3.7 Flash, but Reuters note that Google still hasn't given a release date for its expected Gemini 3.5 Pro flagship, despite saying it in July that the model was being tested with partners and would arrive soon. This is a strange situation. The cheaper Flash model is already on version 3.7. The flagship Pro line is still waiting for its next major release. And this is happening while Anthropic and OpenAI continue pushing their own frontier models. So Google has effectively split its strategy. Flash is moving extremely quickly towards cheap, scalable agents, and Pro is still the test for whether Google can actually reclaim the frontier. And that distinction matters, because if Gemini 3.7 Flash becomes the model that millions of companies quietly use to automate workflows, Google could win a huge part of the AI economy without having the most impressive chatbot. But if Google wants to control the frontier as well, it still has to solve the Pro model problem. So what actually happened to Gemini? I don't think Gemini suddenly became bad. The more accurate explanation is that the AI market moved underneath Google. In late 2025, the race was largely about who has the best model. Google managed to win that race, at least briefly. Then everybody improved, and the industry started moving towards coding agents, computer use agents, enterprise automation, inference economics, and models cheap enough to run at enormous scale. Google's response is now becoming much clearer. It is pushing Flash models aggressively, it is cutting prices, optimizing for agent workloads, and integrating Gemini, and it is betting heavily on its own silicon. The irony is that this may be exactly what Google is good at. Google has spent decades building infrastructure at a ridiculous scale. It knows how to operate data centers, build specialized hardware, distribute software to billions of people, and sell cloud infrastructure to enterprises. Those are all advantages in an AI market where intelligence itself is becoming cheaper. But the weakness is equally obvious. Google still needs to prove that it can consistently produce a frontier model that people consider the best, and turn that technical capability into a product people actively choose rather than merely one that happens to be sitting inside their Google account. The story of Gemini is not really that Google had a great model and then they f***ed it up. It is a little bit more interesting than that. Google briefly won the frontier model race. Then the race changed, and now Google is betting that the next race isn't about having the smartest model at all. It's about having an AI model that's smart enough, cheap enough, and fast enough that it can be integrated through companies who can afford to run it everywhere. And ironically, the company that invented so much of the technology behind modern AI may have decided that it doesn't need to win the chatbot war to win the race in the first place. It just needs to make sure that the intelligence is cheap, accessible, and efficient enough.